So you got your powers chart, and now we're going to show you how you can use your powers chart to solve exponential equations without your calculator. So we'll go to example 1. Example 1a says 4 to some power is equal to 1 over 256. And the question is, are the numbers 4 and 256 in the same column as your powers chart? And the answer is yes. 4 is 4 to the 1. 256 is in the columns of 4, it's 4 to the 4. And what our goal is without our calculator here is if we can write both sides, like in this example, I can write this as 4 to the x, and I can use my negative exponent law and write this as 4 to the negative 4. Does it make sense? If both sides are 4 to something, and this side said, this side says 4 to the x, and this side says 4 to the minus 4, what do you think x is? And you can, I always write, because I'm not actually using a math here, I'm using an observation, I always write, so, does it make sense that the x has to equal minus 4? So in solving these, if we can get both sides to have the same base, and we have 4 to the something on one side and 4 to the something on the other side, then those exponents would have to be the same. So in looking at B is a little bit trickier. 27 and 9, are they in the same column of your powers chart? Yes, they are. They're powers of 3. So I'm going to change the 27 to 3 cubed. It would still put it in brackets. It still has an x. And I'm going to change the 9 in brackets to 3 squared. It still has an exponent of 2x minus 1. Exponent laws say, what do you do with a power to a power? Do you remember? You multiply. So this side is 3 to the 3x. And if I multiply this side will be 3 to the distribute 4x minus 2. And now we're at the point where we can go, so, does it make sense that the 3x has to equal the 4x minus 2? And then just bringing the x's to one side and the 2 to the other side, you get x equals 2. You can circle questions 3, 4, 5, and 6.